Hey everyone. Today, um, we're going to be continuing with KNN model. Yesterday we looked at classification and how that works, and today we're going to be looking at regression. See how this works. So, let's get right into it. It's going to be a little bit different, but most of the concepts are going to be the same thing. Okay. So, what is a KNN model? So the K nearest neighbor is a supervised machine learning algorithm that classifies or predicts the value of a new data point based on the majority class or average value of its K nearest neighbor in the training data. So in this case, we're going to do the prediction. So let's take this data set here. Let's take this graph. Okay, we have size and price here. Okay. Um, and price is the independent variable and size is the dependent variable here. And then we have two types of houses. We have a mansion and then we have a normal house here. Okay. Now let's see how we can use a KNN model to now predict, do regression instead of classification. Okay, let's pretend our data point is right here. So similar data points are located near each other. We learned this in our classification, right? So how can we use this to predict the the value or price of this, all right? Let's just pretend we have some made up values for each of these, right? Let's say the price of this is 1 mil. This is like 0.9 mil. This is like 1.5 mil. And then this is like 300K, say this is 500 and this is 1 mil. Or let's say this is 800. Okay. Okay. So now that we have all of these values for each house, what we can do now is try to understand how this data point is coming here. Um, so we're trying to now find what's the price of this. That's the goal of this type of model using these values. So far, is everyone following along what a KNN regression model does? Okay, yeah, no worries. All right. Okay, yeah. So that's how what like the KNN so the goal of this here is to now predict the price of this random point here. The goal is not to say, oh, this data point is a mansion. Oh, this data point is a house. That's not the goal of this model. The goal is to figure out the value of this house now. Okay. So now that we understand the goal, let's go into it. So if you notice, the steps of the KNN model for regression is almost the same for classification. We choose the K values, right? We calculate the distance between the points like this, and then we sort the distance and pick the K nearest point. And then we get the average. So this is different here. We get the average or the regression to make a prediction. Let's figure out how to do that. So just like yesterday, we calculate the distance using this formula here. So I won't go too much into this. We can just use this formula or you can use the distance formula. The goal of it is ultimately to calculate the distance between these 2 points here. So all we're doing here is we're getting the square root of um, this value minus this value here. And then we're just adding each of the points up. So we're adding this point, this point, this point. We're adding this point, this point. We're adding all the points up. That's what the summation is. We're adding all the different points in inside the square root. So point one, point two, we're getting the distance and adding it. That's how this works. And then we do a square root to calculate the distance. Okay. Now we now sort the distance of all of these. So we sort these distances, right? And after sorting the distance, what we're gonna do, okay, we sort it by lowest distance to highest distance. So closest to furthest distance. So after we sort this distance, we don't use a majority voting system. Let me change. We now calculate the regression of it. We now calculate the regression of this. So now if you notice what's different, we're not putting these to a vote. Instead, we're using this formula here to understand the regression. So how does this work, right? So we have, let's pretend k is equal to 2. Okay. So what do we do when k is equal to 2? We take these 2 points here, right? So when we take these 2 points after we sort them, is now we have to get the average value here. So let's figure out how we can calculate the average value. So we can use a simple formula, right? We can use that formula from before, and let's pretend this is the data set we're using here, right, for the houses. So we have the size and the price here, okay? And then we're gonna calculate the distance. So I already calculated the distance for just some made up values, right? After calculating the distance, I'm gonna use k is equal to 2 here. And when k is equal to 2, we get the nearest neighbors, and let's say the nearest neighbors had a value distance of 240 and 260. Okay. And then what do we do from here? Well, we add them up like this, 260, and then we divide it by 2. And that will give us the prediction value of this. So now this house is worth 250K based on the closest distance. So that's how this works. Does anyone have any questions so far?
I didn't get the formula part. Like, how does the formula work?
Okay, let me go back one. Okay, let's make this simpler. All right, let's say after sorting these by the distance, right? We get this distance, this distance, this distance. Okay, we get all of these distances here. Okay, let's say this distance between this is 50. Right? That's what we're getting. This is 55, and then this is 60. This is like 100. Okay, blah blah blah, right? Then we can sort them, right? We do 50, 55, 60, uh, and then 100. And then, right, we have 50 here. We're not just adding 50 plus 50, right? That wouldn't give us anything meaningful. We check the value of what's nearest. So since this is 50, let's check. Let's just make up a value for this house. Let's say this equals 500K, okay, to make things easy. 500K. And what's the next one? Let's say that is now 700K, okay? That house is 700K. Let's say 60 is 300K. Okay, let's just keep these 3 points for now, okay? Now that you see how we sorted that, and then now do you see how we get these values? Does this make sense so far?
Yeah.
Okay, so once we get this, let's say k is equal to 2, right? So what do we do when k is equal to 2? We grab these two values, right? We sort it from lowest to highest. Then
And
from
we
that
grab the
sorted list,
first.
we take the first two. Yeah, good. First 2 points. Now what do we do from here? We do 500 plus 700, and we get the average. 500 plus 700 divided by 2. So what is that? 500 plus 700 is 1200. 1200 divided by
And
2 is 600. So now, yeah,
6,600.
good. Yeah. So now this is going to be equal to 600K. Do you understand how we're getting
Okay.
that now?
Yeah, yeah.
Okay. So that's how regression works for this type of model. Does anyone have any questions about how this works? No one has any questions? Okay. All right. I'm gonna give another example. I want one of you guys to unmute and try to figure it out on your own. Okay. Let's say this house, let's go. Okay, let's say this house is 400. Okay, 400K. Let's say this is 500. This is 700. This is 200. Oh no. We'll say this is 200. We'll say this is 400 and we'll say this is 420. Okay. Let's say K is equal to 3. Okay, now who wants to give it a shot? Who wants to try this out? We're trying to figure out what this pink point is. It's the goal. Does anyone want to give it a go?
So you would add the three lowest values and divide it by three?
Not okay, wait. I forgot to give you one more piece of information. Okay, let's say this is 20, this is 15. Like this is the distance by the way. 15. Let's say the distance is 40. Let's say this distance is 50 and let's say these are 55 and 60. Okay.
Okay.
Now what do we do from here? So I'm gonna circle the distances. E6. Okay. What do we do from here?
You would order them from lowest to highest, the distances.
Yep.
And then you would take the three closest houses and add them, and then divide it
Yes.
by three to find the
Yep.
other mansion.
Okay, good, good. So just tell me what are the three houses that are close by?
The house that has 400,
Mm-hmm.
500, and 700.
So now what do I do my equation as?
So
What do
you
we do?
add those three?
Yeah. So we do the adding
Yeah,
what? The distance or the price?
the price.
Good. Okay. So we would do 400 plus 700 plus 500 divided by 3. We don't need to actually calculate it, but I just want you guys to understand how this works. So does that make sense to everyone, how this works now? Can I get like a thumbs up or something from everyone? Okay, perfect. Yep, perfect. Okay, yeah, good. Glad this makes sense. So now let's learn like why we use regression versus classification, right? We can use the same thing, but for classification, like the same data set, right? For example, if we wanted to know if the house is a mansion or not, then what would we do? We would use classification. But if we wanted to know if the exact price of this, right, we would use regression. Because what are we doing in this? We're predicting a numeric value, right? We're not predicting a categorical value. So if we want to do categorical values, then we would use classification. If we want to predict a numeric value, then you would use regression. Yeah. Okay. Now I'm going to give you another example. This is tying back from yesterday's work. Who wants to tell me how we can use this to um, get the uh, classification? How can we make this into a classification? Okay. Let's say mansions represent zeros, okay, and houses represent one. Okay. So how can we use this to now classify? I'll just write down the stuff here. So I already sorted it for you guys. I did all the hard work here. Now, how can we now classify using it? Who remembers the equation we used? Hint, hint. It's something with mode.
You would have to order like the numbers of each thing based on how many K values you want and find the mode of them.
Yep, yep, yep. Okay, so let's that was Dia, right?
Yeah.
Okay. Let's say K is equal to 4. Now what do we do? What's the mode of this?
So the mode of this would be 0 because the data set would be 0, 0, 0, 1.
Yeah, correct. So what is this prediction now? What would the point prediction be?
That it's 0, so it's a mansion.
Perfect. Yeah, good job. That's exactly right. I just wanted to clarify you guys on if you were paying attention yesterday, but good job. Looks like everyone was paying attention. Yeah, so um that's how we differentiate between classification and regression, depending on what we want to do with it. So good job, DF, for that. Okay, let's get. Did we do the coding yesterday for um classification, everyone? Or did we not do that yet? I think yesterday I just explained the code, right? Did I actually let you guys code yet or no?
I don't think we did.
Yeah, we didn't do it right. Oh, I just explained it. Okay. So, okay. Yeah, let's do the code for classification, and I think we'll have time because we have a bunch of time right now. I think we'll have time for regression as well. If not, we can just finish up tomorrow. Or wait, today's Friday, on Monday. Yeah. Okay, is my screen still shared? No. Okay.
No.
No.
Okay, thank you. Okay. Yeah. Let's This is day 6. Good. Okay. Okay. All right. So, I want you all. Okay, actually, I'll first explain the regression code, and then I'll go into. I'll let you guys do uh, classification code. Let's go into. Yeah, let's go into regression first. Okay. Let's say we have this data set. Okay, all pandas right here is doing is it's just helping us set up this data. Okay. Okay. So we're taking in square footage, bedroom, and we're trying to predict the price. So these are going to be the independent variables, and the price is the dependent. So we're creating the data frame. So I'm sure you guys seen all these code before, right? We're creating our x variables here, double brackets to indicate it's x. Then we're putting this here, and then we have our dependent variable, which is price. We're putting this into the y variable here, and then we're just doing a train test split. For now, you guys don't really need to worry about this. Yeah, Sanjana, did you have a question?
Your screen is paused.
Oh, is it? Oh, can you guys see this now?
Yes.
Now I see it.
Okay. Okay, let me do that again. So yeah, pandas here. Yeah, I'm using pandas and importing the data frame right here, creating my data frame. Square footage and bedroom is the x variable, and then the y variable is price. So that's the dependent variable. And I'm sure you guys seen the x train, x test, y train before, right? All it's doing now here, I just did 80-20 split right here. So 80 for training and then 20% for testing. I mean, you guys don't need to do the step for your database because you're probably going to create like a small database. But if you use bigger databases, then you really need the step. Okay, here. Now I'm building the model here and then setting the nk value to 3. And then I'm training the model. So for now, I'll just train it with x and y variables. And then this is where the model is actually making the prediction. And over here, who remembers this? What this means? MSE. We learned this in class 1, in our first class. Does anyone remember mean squared error? Anyone want to give it a go? I'll write down the hint.
Loss function.
Yeah, loss function. Good. It's our loss function. So what does our loss function do? Okay, what does it mean if it's lower? Right? What if it means that our loss function keeps getting lower? Does it
It
mean
means
It's
our
more
model?
accurate.
Yeah.
Yes, yes, yes. Good job. Yeah, that's exactly what's happening. Okay. Then here I'm just creating a data frame of the results. Let's see what else. Okay, and then here I'm using matplot.lib to create a graph with the values here. Right. Whenever we're working with regression, we always use MSE or like any loss function like this, right? Because it's not really the goal is not to get accuracy because you're not really classifying anything, but the goal is to like see how accurate it is, right? So that's why we use MSE here and not accuracy for the results. Okay. Um, so this is a data point that it used and it gave a predicted value, 340, and then there was another predicted value here. So that's what the model predicted versus the actual model here. Okay. So this is where the testing phase comes in. That. Yeah. So if we run it again, you see this time I'm giving the entire database and it's much closer. And if you notice, it got better, right? And that's why the MSE value is lower. But is there a reason why usually only the X is capitalized for the training and testing sweat? Um, okay, there's not really a reason why, but it's good practice to always have the X capitalized. That way you can differentiate it. It's just common practice in machine learning to do that. It's not a required step, I guess, but it is common practice to do so. Okay, also on that, I wanted to, yeah. So also on that, Padma, if you noticed here, right? Because yesterday you had a question about the train test split thing. So if you notice, this time I reran the model and I gave it the entire database, right? This time I made a more accurate prediction, but this is not really evaluating our model correctly. It could be the reason it's more accurate is because it's already seen those 20% of data, right? Um, because last when I had it in my old code, like what it was, X train and Y train, this is uh training on unseen data and it's predicting on unseen data. But this time, if I just did X and Y, it would be predicting on um, seen data. It's already seen it, so that could also be the reason why it's making a more accurate prediction. But since I have a small data size, it's better to have it see it. But let's say if this was like humongous, then you wouldn't want the data to already be seen because the model already knows the answers to it. It's like, for example, your math teacher gives you a test, but you already know all the answers, right? You can't really evaluate if you're good at that subject if you already know what the answers are. That's basically what it is. Um, I just wanted to bring that up today. Okay, yeah. Does everyone understand how the code works here? Or do you want me to go over that slower? Okay. All right. I'll take that as a yes. Thank you, Sanjana. Yeah, let's go ahead and create the code here. Okay, everyone. So I want you guys to all. Do we need to put this code in the GitHub, or you guys want to just type it out? What does everyone want to do? You guys can experiment if you want from the scratch, like use your own database that you created? What do you guys want? Or what do you guys want to do?
Could you just send the code in the chat and then I can like just experiment with it?
Okay. I'll put it in the Discord because someone was saying that they couldn't copy and paste from the chat window.
Yeah, all right.
Yeah. I'll be pushing all the code from all our classes soon, as well as all the resources. Oh, also thank you, Sajin, for letting everyone know the time. Okay. Yep. I just sent the code to Discord. Yeah, everyone please look at it. Yep. So I'll give you guys some time to do that, and if it doesn't work for you guys, let me know and I'll help. I want you guys to all come up with a new database, and let's do a little like presentation style today. We'll do like I'll give you guys like 10 minutes to code it, and then I want you guys to do like a presentation on what your code means and what you changed in it. I want you guys to experiment with that. You guys have 1 more minute, but I just want to answer this question in the chat just to clarify things. Um, okay. If you do use more percentage of the data when you train, you do get a more accurate response, right? You get a higher accuracy, but it's not the most accurate thing, if that makes sense, because the model already trained on that data, so it's already seen it. So the more higher percentage you're giving it, like for example, 90 or even 100%, then the model already sees it. So you'll get a higher accuracy for sure, but it's you can't really validate if your accuracy is accurate. So that's why there's a thing called validation accuracy. We'll learn that more when we get into neural networks, but validation accuracy lets you test see if your test accuracy and your train accuracy is correct or not. Because if the validation accuracy is not correct, um, right, it's not matching up, that means that your model itself is weak or you need more data in your thing. So you need to go collect more data. So that's how it would be, but it's common practice to have it around the 80 to 70% range or even lower to have a more stronger model. Okay, yeah, no worries, Kartik. Okay, that's it. Time's up for everyone. So I want who wants to go first on sharing what they did? You're not finished yet. Okay. Okay, I'll give you guys like 4 more minutes. Okay, actually, yeah, I'll give you guys 4 more minutes. We'll have 10 minutes to do presentations. Okay. Um, yeah. All right. Let's get started. Did anyone finish what they? If you didn't finish two, it's fine. I just want to see what you guys have done so far. And who wants to go first? On explaining what they've done on their code. Okay. Yeah. Go ahead and share your screen, Sanjana. Thank you for your volunteering.
I'm not finished yet, but I used a data set from Kaggle about life expectancy in Afghanistan. So these are my data points. I used infant death, measles, and year for my x-axis, and life expectancy for my y-axis. And I put those over here. I have a question.
Yeah.
Over here, it has numbers after the x-axis points. What are these supposed to be?
Yeah. Let me see where you're. Okay. New person. Okay. So those are just new person 50, not different. Okay. Yeah. So those are just creating a random data set of infant death, and it's putting that value as 28, and measles, it's putting that value as 4,000. 43,000. And then it's using that data set to just test the model. That's it. You're just creating a new data set with those values.
Okay,
And it's making a prediction on those and giving you that result.
okay. So in life expectancy,
So
Mhm.
go down a little bit. Let me show you where it's doing that. Okay, keep going down. Let's see. Okay, it didn't give you your prediction because there was an error.
Yeah,
Let's. Okay, but let me show you my code real quick.
okay.
I'm gonna stop your screen sharing and show you. Okay, if you look here, right, in my code, I have age, right, and then I have it as 28. So I'm creating a new data set. Annual income, I'm saying 43,000. Okay, and it makes a prediction here. So it creates a prediction here, and my prediction is non-purchase. So it's using this new data set that I created to make a prediction. That's all it is.
Okay,
Does that make sense?
yeah.
Okay, yeah. Go back to your code. Let me see the error. Okay. Go down. That's not. Okay. Let's see. Yeah, keep the feature names should match those that were passed during fit. Okay, go up a little bit. Okay, let me see where this is happening. Okay, yeah, okay, I see where it is. Go up to the code. Go down just a bit. Okay, let's see. New person, new person skill equals. Should be the error is not related to that. Okay, first of all, change your infant debt and measles to something you actually want to test. Because I'm not sure if this 28 and
Yeah.
43,000 is going to be right for you.
So just a random value that's close to
Yeah.
my data.
Mm-hmm. Yeah. Just something realistic. It doesn't matter.
And I
Okay.
also have to add year, I think, right?
You don't have to.
Okay.
You wait. Hold on. Let me think. No, you don't have to. Yeah.
Okay.
You're only giving it to. You can to make it more accurate, I guess, but you don't have to unless you want to.
Okay.
Okay. Wait. Actually, never mind. You do.
Okay.
I thought measles was your Y. Yeah, you do need to add that as well. I think that's why it's giving you the errors
Mhm.
actually. So just do comma and then the quotation and then write year. Yeah. And then just write something random there.
Um,
Yeah, just do something that makes sense. Actually, go to your. Let me see the Kaggle database actually that you pulled from.
okay.
Did you just manually type it in?
Yeah.
Oh, okay. I'll show you how to where you don't have to manually type it in. Is there a value in here that you haven't used? If there is, you can just
Um,
grab it from it.
okay. Yeah, I can do 2008.
Yeah.
Should I run it?
And then yeah, just run it. I think that should solve your problem. Yep, it did. It did. Your error's gone. You see? Now you have the prediction
It's above
right
or
there.
equal to 59.5.
Yeah. So that's your prediction based on what you put there. Okay, go up all the way up to your code. Life expectancy. Okay. So now you can use that. Go to the Kaggle database there. I can show you how you can directly grab it and then download that CSV. So there's like that download button. Do you see it? It's like right next to
Yeah.
the name.
This one?
Yeah. And then go ahead and drag it into your workspace. Do you know how to? Yeah, just sign in with Google. It's free, so you don't have to worry about anything. Yeah. Did it download?
I
Oh,
think I have to press it again.
yeah, I think you do.
Yeah.
Okay, nice. So now what you're gonna do is go to your code and then drag it into your workspace.
The same as the restaurant file.
Yeah, so you're gonna drag it into the left side, like,
Okay.
yeah, there we go. Okay, good. Now replace the code that says data, replace that entire data frame, just like copy the entire data frame there. Yeah, take out that bracket too when you do it.
Okay,
So
so
yeah, just replace that entire code with PD uh dot read CSV. So you're just gonna and then take out infant debt, all those stuff underneath that.
okay.
Yeah. And then take out that last bracket too. Okay. Read I think it's underscore CSV. Pretty sure. Yeah. Read underscore. Yeah, underscore CSV. Then you're gonna put in brackets. Uh no space, no space. Yeah, in brackets, quotation mark. Then you do the name of your file. So you would do what is it? Yeah, you just like right click on it, right click that file. Oh, you can drag it at no.
I
Okay,
don't know.
just right click the file and
Life expectancy.
yeah. Then click rename, right click, and then there's rename right there. Do you see it? It's like let me see if I can annotate. Oh yeah,
Mhm.
right here.
Okay. Yeah.
And then do Control C and then copy that file name.
Oh, wait. It's over here now. Okay.
Yeah. Then you can go back to your code by clicking here. And then paste that and then do .csv and then quotation and then yeah. Okay,
Okay.
now your code has access to the data set. Now you don't have to do anything else because this is the same, right?
Hmm.
You didn't change anything here.
Yeah.
Okay, good. Yeah, then you can just run this and I think it should work. Okay, let me see
Oh.
there. Not an index. Okay, click on this. Click here. Let me see. Go up. Like, is that the top of your data set?
Um,
Why doesn't it give your column names? Oh, there we go.
Oh,
Okay, so copy and paste this exactly how it is. Wait, you need life expectancy, and then what else is there? Go to the code.
measles and year, but I think it was just measles that had the error.
Okay, I think there's a spelling error then. Just go to oh, your regression code here.
Sorry.
Yeah, sorry. Yeah. Up. Let me see.
Oh, it's infant
Nice.
death and measles.
Oh, infant debt. Okay, okay, go back to the CSV. Do you see infant debt and measles on yours?
Yeah, it's lowercase.
Oh, okay. Yeah. So you want it to match up exactly with that column name and it should work. Is D in debt also lowercase?
Oh yeah.
Okay, now try running it. Oh yeah, that's a good catch. That's also gonna now try running it. Oh, let's see.
Um,
D infant debt measles. Okay, go back. Let me check. Where
oh,
is
deaths. Yeah, it's infant deaths
oh, okay.
and measles. It's capitalized.
I see. You clicked the wrong one.
Yeah.
That's gonna work now. Measles still. I think you just misspelled it maybe. Measles. Me. Yeah. S. What did I say? What's les?
I think I spelled it correctly.
It's weird. Your code should work then. Go to. Okay. I'm not sure. Okay, just try something else actually. Try different. Instead, if not measles, you can just put a different column name
Okay.
that has a number.
Um,
You can
do
do,
BMI.
yeah, BMI. That's easy. Yeah. Just try running that. That's so weird. Okay. Just copy this code and the error, and I'll take a look at it. I'm not
Okay.
sure why it's giving you this error, but I'm sure it's nothing to worry about.
Okay.
Yeah. I'll look at this error and I'll let you know how to fix it next class.
Okay.
But your code is right. I just wanted to show you how it would be if you just import it directly from Kaggle. And it's great that you use the Kaggle database. So good job on that.
Thanks.
Yeah. All right. We'll have a presentation next week then to finish everything up. So you guys have another week to work on the rest of your code. Okay. All right, everyone. Thank you all for joining. If you have any questions, I'll stick around for like a few minutes. Okay. Thank you, everyone. Bye, guys. Yeah, no worries.
Bye.
Yeah. Thank you, everyone, for joining. Yeah, no worries. Yeah. Anyone else have any questions here? Oh, okay. Yeah. Perfect. All right. Bye, guys. Bye, Liam.